when we look at what needs to be done to achieve deep decarbonization, the UN Sustainable Development Solutions Network helped to put a program together called the Deep Decarbonization Pathways Project. You're going to be hearing a lot about that. And the DDPP, as we called it, brought together research teams from many of the big emitting countries to say, what should you do? What should Canada do to deeply decarbonize? What should Brazil do? What should Australia do? What should the United States do? What should India do? What should China do? For every one of the big emitting countries, what is the game plan? What is the pathway to get to zero CO2 emissions from the energy system? Turned out, when we looked at it, those plans were quite similar even across all these very diverse economies. They all had three pillars that you see in front of you. Those three pillars are, first, energy efficiency. If you can get more economic output per unit of energy, that means more economic output per unit of carbon dioxide. That means that for a given size of the economy, we're not going to be using as much energy or emitting as much carbon dioxide. Second, it means decarbonizing the electricity system, because if we can produce electricity not by coal-fired power plants or natural gas-fired power plants, but by wind power or solar power or hydropower or geothermal power or nuclear power, then you can have the electricity without the carbon dioxide emissions. And the third pillar of deep decarbonization is what's sometimes called fuel switching. In other words, not to change the primary energy source, but to change how energy is carried by fuel. And here's the big example: our automobiles. Right now, we put gasoline from petroleum into the gas tank, or diesel into the gas tank. And when the internal combustion engine produces the motion of the vehicles, it releases CO2 into the atmosphere. How about, instead of putting diesel or petrol, gasoline into the gas tank, we put electricity charging batteries of an electric vehicle, and the electricity that's charging that vehicle is being produced by a zero carbon source. For instance, wind power or solar power. So you have a big power generation system. It's running on wind, for example. The wind is generating electricity in a wind turbine. That's charging a vehicle, it's charging the battery's operating. You have eliminated carbon dioxide from the transport system. So that's what fuel switching is. Go from an internal combustion engine to an electric vehicle. Go from a boiler or a furnace in the basement of your building in a cold place to heat the building, to an electric heat pump that uses electricity for the building to be heated rather than burning maybe heating oil on the premises of the building. That's fuel switching. So when we put together the deep decarbonization pathways for all of these big emitting countries in this project, we found that those three pillars were the key pillars for every country. And that's good, because that means there's a lot of know-how about how to get to zero. And the basic way to get to zero is we've got to be energy efficient, we've got to decarbonize the electricity generation, and we have to move from internal combustion engines and furnaces and boilers to electricity or equivalent energy sources like hydrogen. Why do I say hydrogen is equivalent? Because to use hydrogen in a fuel cell, for example, in a vehicle, what you would do is use clean electricity, hydrolyze water, separate the oxygen and the hydrogen, then you would burn the hydrogen in the fuel cell. That would combine the hydrogen and the oxygen back again, releasing energy and producing H2O, producing water as a result, not producing carbon dioxide. So the point is that if we can move our energy systems to zero carbon electricity and switch the fuels in the gas tanks in industrial processes and in our buildings being heated and our homes being heated in the cold climates, we got it made. That's what every country's task is. And when we look at this Deep Decarbonization Pathways project, the name of the game fundamentally is to say, how are you going to clean up your electricity grid? How are you going to make electricity that isn't coming from a coal-fired power plant or a gas turbine, but is coming from wind power, solar power, geothermal power, nuclear power in many places, or a technology known as carbon capture and sequestration, which says, okay, I'm going to continue to burn coal, oil, or gas, but I'm not going to let the carbon dioxide go up into the air. I'm going to capture the CO2 chemically at the power plant, and I'm going to stick it safely underground. Or, even better if it can be done economically, I'm going to take CO2 directly out of the air through chemical processes, and then I'm going to pump it under the ground and keep it safe. So this is really the name of the game of deep decarbonization. The basic point that is almost surely the case is we have to move from a world energy system where roughly 80% of the primary energy that we use in the world today, roughly 80% is coming from coal, oil, and gas, to an energy system where perhaps 80% is coming from wind, solar, geothermal, hydropower, nuclear, and 20% is coming from fossil fuels, all of which is offset by carbon capture and sequestration, or what in the jargon is called CCS, for carbon capture and sequestration. So the big move in keeping the climate system safe when you get down to it is moving from fossil fuels to zero carbon energy sources, especially in electricity production, and then electrifying the places now where on site we are burning fossil fuels, like under the hood of our automobiles. Now, if that scenario is followed by the world, we can make this transformation. We can stay within the carbon budget. We can achieve that upper limit of well below 2 degrees C, and even achieve 1.5 degrees C if we really all work on it together, every country taking the maximum effort. It does mean one important thing. It means we will not be burning all of the reserves of coal, oil, and gas that the coal companies or the big oil companies have found over past decades. We've spent a lot of money exploring and developing reserves. So we have a big stock of oil reserves. We know that in the US fields or in the Middle East or in other oil-producing regions, there's a lot of oil down there. We know there's a lot of gas down there, especially there's a lot of coal. But what we know absolutely without a question is if we burn all that we know about in these reserves, we would so burst the carbon budget, the world would be unlivable. So we have to leave fossil fuels in the ground. Now there's a term that we use for that. We have to strand them. And that's a little bit tough because countries are saying, our economic future, we're a coal exporter, we're a gas exporter, we're an oil exporter. And the truth is we're saying, not for long, because we cannot use your resources. So we're going to go to wind, we're going to go to solar, we're going to go to nuclear. We're not going to buy and burn your fossil fuels. Well, countries that have them, and especially companies that have those reserves, are not too happy about that. They're lobbying like crazy. They're even putting out propaganda. Don't believe any of this stuff about warming, except all you have to do is walk outside almost any part of the world and you know that the climate is changing dramatically. But the oil companies have been telling lies for a long time, at least many of them. Some of them are honest right now, and some of them are still putting a bit of propaganda out there. But we know that we're going to have to strand the fossil fuels, because if we burn everything we have, we are absolutely bursting the carbon budget. Yes, it's true, some part of fossil fuel use might be made safe by carbon capture and sequestration, but probably nothing close to the massive, massive billions and billions, trillions of tons of CO2 that we would emit if we burn all of the reserves of coal, oil, and gas that we know about. So this is really the essence of the deep decarbonization. Leave it in the ground. We still need electricity though, so deploy the wind turbines, deploy the solar fields, deploy geothermal energy, deploy hydroelectric power, deploy nuclear power in some places. Yes to carbon capture and sequestration, but stop the emissions of CO2 lest we wreck the planet. Now, one final point that I want to make about a deep decarbonization pathway for every country and all of you who will be designing these programs, who will be working with your governments, who are in government right now, or are students that are making research projects on how your country can deeply decarbonize. You cannot achieve this by saying, I'm going to look ahead 5 years, and then another 5 years, then another 5 years. You have to take a look 40 or 50 years ahead and say, that's where we want to be, zero. And now, how do we go from there in 2050 back to here in 2016 or 2017? That's called backcasting. That means asking where you need to be and then what you need to do between now and the future to get to where you need to be. And a big point that we've been making in the UN Sustainable Development Solutions Network is it's not good enough to have a short-term plan that says, oh yeah, we're going to reduce emissions 20% and we're going to do it by going from coal to gas, for example. Because that doesn't solve your zero problem. You have to get to zero. Don't go from coal to gas. Go from coal to sunshine. Go from coal to wind power. Go from coal to hydroelectric. Go from coal to nuclear power. But don't think that short-term measures are going to add up to the long-term solution. Look ahead 40 years. Don't get trapped in short-term detours or dead ends. So sometimes in my country, in the United States, we say we're going to go from coal to gas by 2025. We're going to have better internal combustion engine cars, and that'll reduce our emissions, say 25%. And then we'll move on from there. And I say, no, wrong way to think about that. Because we don't want to build a natural gas economy. We want to build a wind and solar economy. We don't want better internal combustion engines. We want electric vehicles that really emit zero. So the point is, by realizing we have to go all the way to zero, you can avoid getting trapped in short-term dead ends, which if judged on a short horizon, look, okay, that's progress, but puts you into a new trap rather than putting you on a path all the way to zero.